Earlier we looked at the structure of an XML document. Now I want to see how we can use XML in code. I use XML in Scala in part because it's very, very easy to do so. So there are two aspects of using XML in a program. One is how you build up XML inside of your program, either loading it in or just manipulating things. And the other is how, once you've brought something in, how you parse it into pieces. So this was the document that we created last time. I added a little bit more for a draw text kind of to complete it. I'm going to close a few of these. And what I'd like to do is maybe do something like this. Let's go ahead and let's do a new app, use XML. Okay. So, one of the things about XML and Scala, and part of the reason why it's so easy to work with, is that you can just put XML directly inside of your program. I should note that this is something that will probably be changing at some point in the future. Now, there is an issue here in that it turns out that Eclipse, now if you install Scala, if you're running this command line or whatnot, you might not have this issue, but it turns out that Eclipse does not by default give you the Scala XML libraries. And so we need to add those into our build path. I will add an external jar. We've already added our Akka stuff and our Scala FX stuff. And so I also need to add the Scala XML library if I want to be able to do stuff with XML. Okay, so I can type this directly into here. Let's say I had some additional values in here. Okay, and I want to include these in this. If I include them, for example, as attributes, you can include things that are just Scala code inside of curly braces. So basically, and you might have noticed sometimes you get interesting errors in Scala with less thans, and that's because it's trying to see if the less than is starting off some XML. You can revert back to Scala by putting curly braces. One thing to note is that if you're going to make an attribute, it's not happy with attributes that are numeric values. You have to convert them to strings to make them happy. Okay, and I could also put something like that in there as well. Okay, so whether it's in the text, in the attributes, whatever, going to curly braces allows you to evaluate Scala expressions, and these can be more complex expressions that wind up being merged directly into your XML. Okay, what about loading in XML? We have an XML document that we wrote, so it's here, drawing.xml, and I'd like to load that in. Well, in the XML package, there is an object called XML, and it has a load file method, which can either take a file or a name. So I am going to, I did not capitalize the file name, drawing.xml, and I'm going to store this inside of a val again. And then just to make sure it works, we'll print it out. And there you go. Okay, so it's very easy to load in XML. If you hover over this, you'll see the type is called elem. There are a number of types in the Scala standard library that represent XML. Now, if you are just looking at the main API, you'll note that there's nothing for XML. And this is because if you want to find the XML, we need to go into documentation, and I'm looking at the 2.12 documentation here. You'll see there's a separate XML API, and you have to pull that up, and then inside of Scala there is an XML package, and you can see the things that are inside of here. There is this elem class, which extends a type called node. So the elements are subtypes of node, and node extends a type called node sequence. Okay, so we wind up dealing a lot with these node sequences, and as the name implies, a node sequence is just a sequence of nodes, and it has the methods, because it extends sequence, it has the methods that you expect to be able to call on the sequence type in Scala. So we can do things like mapping or whatnot. It also has methods for finding stuff there, and those methods are backslash and double backslash. There's actually a standard for XML that uses forward slash and double forward slash, but the double forward slash is a comment, so they weren't able to use that in Scala. And these search for things inside of an XML document. So xdata is this outermost element called drawing, and I would like to pull out the drawable that's inside of it. So the root is that, and we could print out root just to see what that looks like, make sure that we have the right thing. What the slash does is it searches for everything inside of the top level of whatever XML node is passed into here. So this found that top level drawable in there, and then if I were to search inside of root, I could get these values here for the different drawables that are inside of there. I also might have an interest in getting hold of the different attributes, and there is one minor thing that we need to do differently. So I'll say value 1 equals, if I'm looking inside of root and I want to find one of the attributes, I put the name of the attribute after an @ sign. So if we run that, we get 0.0, which was the value for my value 1 here. You'll note that the order of these things is not the same order that we have them in our file here. Turns out that really doesn't matter. The ordering of attributes is unimportant. The ordering of sub-elements, the rectangle comes before the text. That's important, and that is maintained. But the ordering of the attributes is not. So there's also a slash slash, and it's interesting to show what would happen if we did. Another thing to note that value 1 is a node sequence, but of course it looked like 0.0. What if I wanted it to not be a node sequence but to be the double 0.0? Well, the first thing I would have to do is get out the text from that node sequence. Run this again, there's 0.0, but now this is a string. But of course I can convert a string to a double by calling toDouble. There is no toDouble on node sequence, so I have to call the text first. Now I'm still printing 0.0, but now it's 0.0 as a double. I'm going to do one more print line here, and I am going to look at what happens when I take, sure, let's do root. Actually, I'm going to do 2 print lines. And I'm going to search for the @x inside of it. And then I'm going to do the same thing again, but with 2 slashes to make it clear what the single slash and double slash do. So this is the printout for value 1, and then there's a blank line, and then it printed 0, 1, 0, 0. Yeah, that's a little bit cryptic to read. What's going on there? Well, I believe that's a 0 and 100. Remember, this is a sequence, and they're just printing out the elements right after each other. It might be nice if we did something like on both of these, where we do an MK string and separate them by commas. And now you can see it's 0 and 100, because inside of our file we have two x's. One is a 0, one is a 100. The single slash only searches for things immediately inside of the root. There is no x for drawing. There's also no x for this drawable. So if I had done a search inside of root for x with a single slash, I wouldn't have found anything. The double slash goes deep inside of the structure and finds everything that is a match. So I could find every drawable inside of drawing if I use two slashes. In this case, I'm finding every x, which is these two, which are on separate drawables. I have to admit, I don't use slash slash all that much, and part of the reason is because when we did this, we lost the information about which x is associated with which drawable. Sometimes maybe that's fine, but a lot of times I want to know which attribute is associated with which drawable, and in order to make that work, I generally wind up doing single slashes and going down one piece at a time. So we're going to work now on seeing how we could serialize objects, for example, inside of our drawing program using XML. We also want to take our drawing program and extend it so that we can serialize things with default serialization. So we'll have two different ways that we can save our drawings. One, we'll save something that looks like this as an XML document, and the other will save that binary format that we have seen previously.